antiderivative of monomials. Now let's continue on with this example. So to find the antiderivative of 8x cubed, first we're going to rewrite the constant 8. Then we're going to add 1 to the exponent. 3 plus 1 is 4. And then we're going to divide by 4. Now let's repeat this process for the next one. So the antiderivative of 3x squared is going to be the constant 3 times x raised to the third power divided by 3. Now what about the antiderivative of 6 times x? If you don't see a number, it's always a 1. This is 6 times x to the first power. So just like before, we're going to rewrite the constant 6, and then the variable, add 1 to the exponent, 1 plus 1 is 2, and then divide by that result. Now, as was mentioned before, because we're dealing with a definite integral, we don't need to write the constant c here. But we do need to write our limits of integration. So now let's simplify this expression. 8 divided by 4 is 2. So we have 2 times x to the fourth. 3 divided by 3 is 1. So that cancels. So we have 1x cubed, which we can write as just x cubed. 6 divided by 2 is 3. So then this is going to be plus 3x squared, evaluated from 2 to 3. Now this is going to equal f of 3 minus f of 2. And keep in mind, this expression here represents lowercase f of x. And this expression is the antiderivative, which represents capital f of x. So we're going to plug in 3 and 2 into capital f of x. So in these brackets, we're going to put f of 3, and here this is going to be f of 2. So let's plug in 3 into this expression. So it's going to be 2 times 3 raised to the fourth power plus 3 raised to the third power plus 3 times 3 squared. Now, let's substitute x with 2 in the second set of brackets. So we have 2 times 2 to the fourth power plus 2 to the third plus 3 times 2 squared. So this is f of 3, and this here is f of 2. So at this point, we just need to do the math. 3 to the fourth power is 81, and 81 times 2 is 162. 3 to the third is 27. 3 squared is 9 times 3, that's 27 as well. 2 to the fourth power. If you multiply 4 2's, you're going to get 16. And 16 times 2 is 32. 2 to the third power is 8. 2 squared is 4 times 3, that's 12. (27) plus 27, we no longer need the brackets anymore. 27 plus 27 is 54. 32 plus 8 is 40. And 40 plus 12 is 52. So this is minus 52. 54 minus 52 is 2. 162 plus 2 is 164. So this is the value of the definite integral. Now this value here, 164, represents the area under the curve that is between the curve represented by that function and the x-axis, between the x values 2 and 3. So that's what the definite integral can do. It can help you calculate the area under the curve. But that's a topic for another discussion. For those of you who want more